All right, so good morning. Today is May 26th. Okay, perfect. Thank you. Good morning. As always, try to have a notebook and paper and a pencil with you, and if possible, calculator, so that way we can actually try to solve some problems. I will admit today's lesson is a little bit challenging, but just try to follow along the best you can, okay? So how are you guys feeling between a 0 to a 10? How are you feeling? Go ahead and type that into the chat box. I'm feeling pretty good, but I could be better. I see any? Good. Okay, that's a good number. 1. I'm glad you're in that green zone. And then I hope to hear from you, Eric, and how you're feeling, okay? All right, so let's go ahead and look at our objectives for today. So we're going to review solving systems of equations by substitution, which is something we were working on last week. And then we're going to do solving systems of equations by elimination. So before we even do that fully, I want to make sure that we review something that we've been doing from the start of the school year, which is solving for n. Let's see. If you know what to do, let me know. Or if you know the answer. But what I'm going to do is I'm going to take you step by step just as a reminder, okay? So this, instead of an equal sign, we have what's called an equality symbol. So this means less than. So I'm going to make this my line. Why? Because remember, I like to separate the two sides, so that way I know which side, or where like the two expressions are divided. So the goal is to solve the inequality for n. So I want to find n by itself, okay? So if I want to find n by itself, I look at this side of the inequality and I notice that it has 3 with it. So I need to multiply each side by 3 because I want to get rid of the 3. And if it's division, the opposite is multiplication. Whatever I do to one side, I must do to the other side. That gives me n is that. Now, if I go ahead and multiply that out, I know that 3 times 7 is 21. 3 times 1 is 3 plus a 2, 51. This should be your answer. Another way to write it, if you don't want to write it like this, 51 divided by, and I know we're used to writing n first. Remember that if you write it this way, the symbol does flip because you're flipping the whole equation, okay? Question 2, now this is the one that we worked on last week. This is solving systems by substitution. So what I'm going to do is 6x minus 4y equals negative 14. And then I have y is equal to negative 4x minus 13. So this second equation, notice y is by itself, right? I'm going to take all of this where it says y, because it says y is equal to that. And I look for my y. So y is equal to 4x minus 13, or negative 4x minus 13. So I'm going to plug that in. So I take 6x minus 4, because that's the minus 4. And then I have my y. But instead of y, I'm going to put what it tells me to put, negative 4x minus 13. And then I solve for x. Here, I have to do the distributive property. Remember, anytime there's a number in front of the parentheses, I go like that. Okay. And then I go ahead and I distribute. And that's a good question. So right now, I know it's really, I'm so used to having Ms. Ross with us. But today she is at the school actually helping clear out some of the lockers and things like that because Ms. Enrique's assistant principal needed help with clearing things out of the school because since we're not coming back the rest of this school year, they just needed to make sure that every student gets their things back that were in the locker and all of that. So they're gonna clear those out today. So that's where she is. She's helping with that. All right. So when we're looking at this, we go 6x, and then we go minus 4 times negative 4x, and that's positive 16x, because negative 4 times negative 4 is positive 16, and then we have that x. And then we go negative 4 times negative 3, and that's 52. And then we have that. Okay. Now we combine like terms. So we look at the two values with x and we put those together. 6x plus 16x is 22x plus 52 equals negative 14. And now we should definitely know what to do here because we're trying to get x by itself. So we like to do the line, subtract 52 on each side. That cancels out. 22x is equal to, and then I go, that's that. Divide each side by 22. And that means x is equal to negative 3. Okay. Now, right away, if I know my x is negative 3, I can already look at these answers and figure out that there's only one that has negative 3 in the x place, and that's C. So right away, I can figure that C is probably going to be my answer. But let's double check. So what I'm going to do is I'm going to take my equation, one of my equations, and I'm going to plug in the negative 3 that I got. Oops, that should be, I don't know why I put equals negative 13. That is not correct. And I know that this is a lot of information right now, YouTube, but we're just going to have to do the best we can with it. So negative 4 times negative 3 is 12, and then it was minus 13. Y is equal to negative 1. So notice this is correct because the y is negative 1, x is negative 3, and that's exactly what we got. So our answer is C. All right, give me 1 second. But, okay, so let's look at this problem. Are you guys ready? It says you're going to the mall with your friends and you have $200 to spend from your recent birthday party. You discover a store that has all jeans for $25 and all dresses for $50. You really, really want to take home 6 items for clothing because you need that many new things. So this is a problem we're going to look at the end. All right, so I want you guys to go ahead and review these problems. And then you said jeans. Let me see. Go ahead and go look back. Oh, okay, so jeans, yeah. Okay, so maybe it's not for this specific problem. Maybe it's not you, or maybe it is. We're gonna pretend I wanted to buy all these things. Okay. Before we solve it, let's look at the steps to solve using elimination. So here it says this shouldn't be here. It should be 3, 4, and 5. Okay. So pick one of the variables to eliminate. You eliminate the variable chosen by converting the same variable in the equation to its opposite. You add 2 new equations and find the value of the variable that is left. And then you substitute back into the original equation to attain the value of the second variable. And then you check. Okay. All right. So this is where I'm going to need your guys' help. I'm going to have you guys participate. So make sure you're typing into the chat box because I'm going to ask you questions. And I hope that you guys are able to answer these. They shouldn't be difficult. I know that these are things that you can do it because this whole process of elimination using solving systems of equations can be a lot. Like it's a lot of information, but I wanted to break it down. So I know that you guys are able to do this part. Okay, are you guys ready? So it says, in order to eliminate a number or a variable, we add its opposite. So in order to get rid of something, you add the opposite. So remember how we do in when we're solving for x. Whatever you do to one side, you do to the other side, and we always do the opposite. So in this case, we're going to do the same thing. In order to eliminate, we're going to do the opposite. So these are the numbers we're going to look at. Okay. So let's start with 5. What is the opposite of 5? And I know you guys know what's the opposite of 5. Negative 5. Okay. So now we're just going to continue doing that. What's the opposite of x? Good, I see both of you responding. Now we're doing, okay, so this is a good point. So the opposite of x does seem to be y, but it's actually not. It is, let me show you. It is negative x, okay? Because I know like we always do x and y, so they seem to be opposites. They're just two different numbers that coexist. But the opposite of x is negative x, okay? Because it's like the same thing, like x, so let's say if x is 3, the opposite would be negative 3. Okay? So just keep that in mind. The opposite of 3y is negative 3y. Okay? And then the opposite of negative 3.5x is positive 3.5x. You guys see that? How like the opposite is always, if it's a negative, the opposite of it is a positive. It's a positive, the opposite is a negative. So go ahead and try it in the chat box. I want to see you guys do 1, 2, and 3. I want you to write down the opposites for each. And I'll give you guys about maybe less than 2 minutes to type it in the chat box. So the opposites of 1, 2, and 3. Okay, so see whatever your answer is good, and then keep it going. Good, okay, really good. So I see, good, Eric. And then good, Juan. Okay, so far what I've seen you write is 30xy, the opposite is negative 30xy, good. Negative half x, the opposite is half x. And notice this is the same thing as this. It's also the same as, when they put, let me do it on this side, 1/2 like that, that means this. It's just sometimes it's hard to type it in, so they type it like that. And then 15y is negative 15y, so good job with that. All right, so we're gonna keep practicing eliminating, but this time, we're gonna do it with equations that look like this, okay? So we have a group of 2 equations. I need to find what I can eliminate from these 2 equations. So I'm gonna divide up the x's, so notice this is x. Here, let's do like this. 3 groups, x's, y's, and then the numbers that don't have any coefficients. Notice this is a 7 and that's a negative 7. Can those cancel out? Yes, they can because they're opposites. 7 and negative 7x, negative 7x, they're opposites. So guess what? That's what I would cancel out. Notice these are different. I can't cancel them out. And these, I can't cancel those out either. Let's look at question number 2. So again, we're going to do the same thing. I'm going to split up the ones with x, split up the y's, and then leave the numbers. Here, by looking at that, I know that I can't cross those 2 out, can't cross those 2 out. But look at the negative 9 and the 9. I can cancel that out. Okay. I'm gonna have you guys do good, thank you. I'm gonna have you guys do this one with me. Or I want you to tell me what can I cancel out from this equation. Good. So I saw the 4x, exactly, because we have negative 4x and positive 4x. So when I give you two equations like that, that's the first thing you should look for is there something I can cancel? Okay. This one's gonna be for Eric. Eric, what can I cancel here from these groups? Group 1, group 2, or group 3? So again, the group, good. So you have group 2. And then is there anything else you can cancel? And this goes for either one of you. Good. So these two would cancel, it's groups 2 and 3. And then we're just, okay, so now this one. Is there anything we can cancel? So group 1, group 2, group 3. Okay, no, exactly. So not right away. But what if I made these all the opposite symbol? So what if I made this, instead of positive, I made this negative. Instead of positive, I made this negative. And instead of positive, I made this negative. But if you change one of the signs, you have to change all of the signs, just as a heads up, okay? If you change one of the signs, you have to change all of them. So now that I did that, now that I changed all the signs of one of them, can I cancel? And I saw your answer and it's yes, because notice this group, all of a sudden I can cancel. Okay. Let's look at our next one. What can I cancel here? What can I do? Okay, so you said group 3. Nothing? All right, so here, there's nothing I can cancel because right away, because there are no opposites. Remember, I need opposites. So what I'm gonna try is I'm gonna change the sign of all of the numbers in one equation. So I'm gonna make this, if this is positive, I'm gonna make it a negative. This is positive, so I'm gonna make it a negative. This is positive, I'm gonna make it a negative. Notice I changed the sign for all of them. Now can I cancel? I sure can. Thank you. Saw that. I can cancel group 1. Okay. So notice sometimes you have to change the sign in one of the equations in order to be able to do that. It won't always be as easy as the top one. All right. What do I do here? And I want you guys to tell me what to cancel, what not to cancel, what to change, what not to change. So let's do this. What equation would I turn this into to be able to cancel? Good, 1. Good, I see Eric, what you said. What, this equation right here, what would I have to change it to? What happens to the 9x? What does that become? Good, 1. So what does the 9x become? Negative 9x. Do I stop there? No, good. This one also turns into a negative, and this one also turns into a negative. So then I look at my groups. As Eric said, I will be able to cancel the first one, but that's only when I do that extra step. If I don't do that extra step, I cannot cancel. And this might be our last problem for today. Okay, this one's a little bit on the trickier side, but you guys will get it, hopefully. Oh no, we might have 2 more actually. I don't know. Can't remember. All right, so here, this is where it gets a little bit tricky because if you look at them, none of the numbers are the same in each group. Where the X's are, they're not the same. Y's are, they're not the same. These are not the same. So it's hard to determine what can I cancel. But what you can do is you can multiply by something to be able to cancel. So for example, I think I want to make this -2. I'm sorry, this +2 into a -12. Or, sorry. In order to be able to cancel, I'm going to need these to become the same. So I'm going to focus on the x's. I want to make this x become a +12. So what I'm going to do is I'm going to multiply all of it by 6. And I'll show you what I mean. All of it by 6. So this is going to become, instead of 2x, it's going to become 12x. Good. But remember, I have to multiply it to each one. So 6 times 8 becomes 48y. And then 6 times -26, that's somewhere like, let's see, 6 times 6 is 36. Put the 3 at the top, 12, 13, 14, 15. That becomes -156. So looking at my new equation, so now I have 12x plus 48y minus 156. As long as I do even if I multiply by whatever number I multiply, I have to do it to all of them. But which group can I cancel out now? Hopefully you got that the group I can cancel out. Okay, so you think it's 3? Well, look at the group that has the same numbers. Look at group 1. Notice how now they're both 12x. It's 12x and then -12x. So that's what you could cancel. Okay. All right. So we do have a few extra practice problems, but we only have 4 minutes left of class. Okay, so let's go to the next one. All right, let's do a quick 3-read. This should be really fast. Are you guys ready? I'm gonna do my 3-read and I want you to answer the question. So you're going to the mall with your friends and you have $200 to spend from your recent birthday money. You discover a store that has all jeans for $25 and all dresses for $50. You really, really want to take home 6 items of clothing because you need that many new things. So first read, what's the problem about? Type that into the chat box. What is the problem about? And then even as you go ahead and type that out, okay, good. I saw one answer and it said buying at a store. And then Eric, if you have something different, I can add that too. My second read, you're going to the mall with your friends and you have $200 to spend from your recent birthday money. You discover a store that has all jeans for $25 and all dresses for $50. You really, really want to take home 6 items of clothing because you need that many new things. What math information is given? So go ahead and type, what math information do they give you? And then good, Eric. Okay, so my next question was, what math information do they give you? Good. So I saw 25, well, 25. Okay, so I saw a lot of, oh, yes, good, okay. So we have $200 to spend. You guys are missing one thing. Let's see if someone figures it out. $25 for all jeans. And then $50 all dresses. And there's one more thing. Well, you guys, good, and 6 items. 6 items. And that's all in here, the 200, the 6, the 50, the 25. And sometimes they type things out, so just careful. What math questions can we ask? You're going to the mall with your friends. So think of, okay, good, thanks, Eric. And I like that you use the term agree, I agree. Start typing in what math questions can you ask about this problem. So you're going to the mall with your friends and you have $200 to spend from your recent birthday money. You discover a store that has all jeans for $25 and all dresses for $50. You really want to take home 6 items of clothing because you need that many new things. What math questions can we ask about this? Because they didn't ask any math questions, but what can we ask? Like, what can we figure out using that information? What are some, or maybe we might need more, but what's something we can figure out? And then try to type in a question. If you really have no idea, still type in a question just so, oh, good. Okay. All right, good job, you two. So how much does she have left? And that's after she buys maybe 6 items. Like, does she have any money left over? And then how much does it all cost? Okay. And then I would maybe even ask a question, okay, like, what did she buy? Because she's, or he, or you, whoever it is, right? Like, if they want to buy 6 items of clothing, we need to figure out, well, how many jeans is she going to buy? She or he, are they going to buy 5 jeans and 1 dress? Are they going to buy 3 jeans and 3 dresses? Like, how much? We're not going to figure that out today because this is something we're going to do next time. All right. So if you haven't done your do now for today, please do it. It's in red because that was supposed to do before class. Finish the exit ticket. That will be available after class. It's the same thing we did today, figuring out what to eliminate. So get that done so you don't forget. Try to do it right after class. And then complete the do now for Tuesday. That's up on Schoology also. The reason it's red is because that should have been turned in already. Yellow means it's due soon, and green means that one, if you do it today, you're kind of early on it. And that's it for today.